Welcome to the next video of the third section, Creating Broader Visual Elements. In the previous video, we have learned how to finalize the data structure. In this video, we'll learn how to create broader visual elements. Let us lay out the broader visual elements of our program. For the sake of modularity, we divide the program into 4 broad visual sections like this. Let us define a method called init_GUI that is called from within the _init_ method, as in the code 3.03.py. We then proceed to define all 4 of these methods. The code is not discussed here, as we have done similar coding in previous sections. Further, we need 5 more attributes to handle the 5 new widgets. We begin with the top bar section. The top bar is simple. It has a few labels, 3 spin boxes, and an entry widget. We will not reproduce the entire code here. See code 3.03.py, as we have already seen examples of creating labels and entry widgets several times in the previous section. For the spin box, the options are specified in the code. Next, let us code the create_left_drum_loader method. This again is pretty self-explanatory. We create a loop in the code 3.03.py. Before we proceed to code the create_right_button_matrix method, let's finish coding the create_play_bar method, as it is the simpler of the two. All it contains is 2 buttons, a check button, a spin box, and an image. We have coded similar widgets earlier, and so I will leave it for you to explore on your own. See code 3.03.py. Next, let's code the create_right_button_matrix method. This is the most complex of all. The right button matrix comprises a 2-dimensional array of rows and columns. The number of rows in the matrix equals the constant max_number_of_drum_samples. And the number of columns represents the number of beat units per cycle, and is calculated by multiplying the number of units and the number of beats per unit. Accordingly, the code that creates the button matrix looks like this. The associated code for the find_number_of_columns method is: we have already created the buttons matrix, but we want the buttons to be colored in 2 alternating shades. Therefore, we define 2 constants. This can be any hexadecimal color code or any color from tkinter's predefined list of colors. We also require a 3rd color to represent the button in a pressed state. The constant button_clicked_color equal green takes care of that. We then define 2 methods. The idea is simple. A button is to be colored green if the value of the button is found to be true in our data structure, or else the button is to be shaded in patterns of color_1 and color_2 for each alternating unit of beats. This alternating color is obtained by using this mathematical formula. Recall that we had created a 2-dimensional Boolean list called is_button_clicked_list as a dictionary item in our original data structure to hold this value. We changed the color of the button to button_clicked_color if that value is found to be true. Accordingly, we define a getter method to get the value of the button. Now, each button is attached to the command callback named on_button_clicked, which is coded like this. Notice something fancy with this piece of code? This method defines a function within the function. It does not return a value as is typical of functions. Instead, it returns a function that can be executed at a later stage. These are called higher-order functions, or more precisely, function closures. Why did we need to do this? We had to do this because each button is identified by its unique row and column-based indexes. The volume row and column values are only available when the loop runs at the time of creating the buttons. The variables row and column are lost after that. We therefore need some way to keep these variables alive if we have to identify which button was clicked later on. These callback functions come to our rescue as they encapsulate the row and column values in the function that they return at the time of creation. You can find more information about function closures at this site. When we define a method called process_button_clicked, The key section in the preceding code is the line that sets the button value opposite to its current value using the not operator. Once the value is toggled, the method calls the display_button_color method to recolor the buttons. Finally, let's complete this iteration by defining some dummy methods for now and attach them as command callbacks to the respective widgets. That completes the iteration. Now, if you run the program, it should display all the broad visual elements. The buttons matrix should be colored in 2 alternating shades, and pressing the buttons should toggle its color between green and its previous color. All other widgets remain non-functional at this stage, as we have attached them to non-functional command callbacks. We will soon make them functional, but before we do that, let's do something to make all our future coding simple, clean, and elegant. Defining getter and setter methods. In our previous section, we needed to know the value of a button in a given row and column of the button matrix for a given pattern. If the value was true, we colored the button green. If the value was false, we colored it in alternating shades. We can get the value of the button by calling this line of code. Notice how this line has 4 sets of square brackets. Since this nested, superscripting business can soon get ugly, we encapsulated this logic in a method named get_button_value row column. Now, whenever we need to get a button's value, we can simply call this method with the right parameters. Now our code will not be littered with those ugly nested superscripts. Whenever we want to get the value of a button, we can call the method get_button_value row column, which has a nice indicative name for the work it does. Isn't this much more readable and comprehensible than its rather ugly counterpart? One thing is for sure, all logic that we build from now onward will heavily rely on data we get from or set to our data structure. Given that we will need all this data all the time in our program, let's write its getter and setter methods in advance. This will certainly make our life a lot easier. The goal for this part of the iteration is simple: to define getter and setter methods for all the data that we have decided to store in our data structure. The code is in 3.04.py. That is all there is to coding the getter and setter methods. The code should be self-explanatory if you've understood the underlying data structure, as all that we do here is to either get the value or set a value for various items in the data structure. With these methods now handy, let us complete coding the functionality of widgets we had earlier left uncoded. The number of units and beats per unit features. We earlier coded the create_right_button_ matrix, which creates a 2-dimensional matrix with the number of rows equal to max_number_of_drum_samples. The number of columns would be decided by multiplying the number of units by the beats per unit values selected by the end user. Its formula can be given like number of columns of buttons equals number of units times BPU. This means that every time the user changes the number of units or the beats per unit, the button matrix should be redrawn to change the number of columns. This change should also be reflected in our underlying data structure. Let us add this feature to our drum machine. We had earlier defined 2 dummy methods, on_number_of_units_changed and on_BPU_changed. We modify them now by using code 3.04.py. Both preceding methods do 2 things. Modify the data structure to reflect the changes in BPU or number of units. Call the create_right_button_matrix method to recreate the button matrix. Now, if you go and run the code 3.04.py and change either the values of number of units or BPU, the button matrix should redraw itself to reflect the change. Awesome! In this video, we've successfully learned how to create broader visual elements. In the next video, we'll see how load drum samples.